Yeah, everybody's seen one of those, maybe scan one with a phone, seen them on a product, whatever it might be. There are different types. So a lot of people, may refer to everything as a data matrix or refer to everything as a QR code or just call them 2D codes. But they do have different methodologies on how they read and do have application-specific reasons of why you would use one or the other, just like you would have with any of the other types of codes. So you can see there, and we'll talk about kind of what characterizes a little bit more, but the data matrix is the L pattern. The QR code has the 3 targets that you can see, and then you have the Aztec code with the target in the center. History-wise, data matrix typically is going to be US and Europe manufacturing. That's who really standardized on data matrix. This is, at this point now, an Omron-owned patent. It's gone through lots of different combining of people all the way back from being the military originally with ID Matrix, through a company RBSI, through Microscan, and now part of Omron. QR codes were designed for automotive in Japan by Denso, and typically used in either Japanese automotive or, as most people have seen now, in printed marketing. So that is a common reader being able to be scanned by cell phones. It's not that cell phones are better at reading that, it's just that because of all of the marketing, because of, digital business cards, menus, everything else, that has become the standard, and so that's what's been developed around that kind of reading. And then finally, Aztec. This can hold more data, but it's pretty uncommon out there. There's not a lot of applications using Aztec anymore. It has fallen the way of HD DVDs and Betamax and all of the other alternative technologies that didn't gain wide usage. So now that we're looking, we saw how the other codes were combined and what made up those. Now let's look at the matrix type codes. So now it's 2-dimensional data. You have a square-shaped cell, and you'll see that cell existing, all over the code. If it's on the inner part, which we can see everything here, that inner grayed out part on the or the blackened part at the bottom, that's your data. That's where the data exists within the code. It is redundant data, so unlike the 1D code where the redundancy was in the height, now we encode in both directions. So our redundancy is in the actual algorithm itself, typically called ECC 200 is what the main one used now if you're encoding codes. But all of that data, you can damage that on the inside, and there are other bits that will pick up the slack on the code. But the important part here is we get back to that quiet zone that we had on the other codes. Here, we're looking at an L pattern. That's the locate for data matrix, or that's the targets in the QR code. That's what's going to help us find this code and find the size of the code. So that's what, when you look at algorithmically how barcode readers are going to go out there and try to find codes, they're going to look for a square, and then they're going to look for the L pattern to orient the code in one direction. Then it's going to use that clock pattern that you see on, off, around the top and the right, and that's what's going to define where the data is internally. So once you have that information, it's going to overlay a grid and then decode the data. And that's the basics of how barcode reading algorithms are going to work, and we can get into how you can make that signal, which we have here, a signal, to make the noise less and the signal higher so we can encode data and then read it out more regularly. Everything that you see at the top, as well as what we showed there around the outside as the quiet zone, that's all going to be considered the fixed part of the pattern. And that term will come up other times, but that is fixed, and then the data obviously being our data region of the code. And you can see kind of the point here now. At the top, it shows the same exact information in all those codes, all printed at the same resolution as well. So you can see what a code 39, and actually, reasonable code 128, definitely one of the smaller of the 1D codes, but you can see how much more information we can get to a small area with that data matrix code. So this is where everything is going, including UPC codes in the next 6 years. So for the most part, with the way technology is going, 1D codes are more or less going to be phased out for any application where it can be, looking more for that data matrix style or QR like you saw on the back in order to house more data as we now produce more things and want to contain more information in one smaller space. And the things you start getting when you go to that 2D type matrix is you start getting 360-degree reading, all in the same area. You're not trying to read it with a laser and have to have that position where we have our line going straight across this long section. That's a long ways to be perfectly even across the laser. You have low contrast reading based on how the actual algorithms work, where we're locating and then overlaying a grid as opposed to looking at highs and lows and creating a waveform that way. And then the error correction, like we talked about. So you can see that's a little Allen wrench or something of that sort. Might be a bike pump needle over top that code. So because there's enough information to locate the code, because that's clean, and then there's plenty of clock pulse, we can just cover that up like that and it's still going to read just fine. All right, so that's the basics of what make up a code. Any questions on any of that information? And now we're going to get into what makes up an imaging system in order to detect the codes.